Hello everybody. In this week we will discuss about chapter 1 of the course Electrical and Electronic Equipment for Industrial Machinery. In this chapter we will discuss about the concept of circuit, fundamental electrical laws, and analysis of DC circuits. And learning outcome for this chapter is LO 1.1. Understand concept, term, quantities related to electrical circuit. And the second one is LO 1.2. Understand the concept, definition, term, structure, working principle, and technical specification of basic elements in the electric circuit such as the resistor, capacitor, inductor, and power source. And the third one is explain the working principle and analyze basic quality of DC electric circuit. Now we will discuss about the concept of circuits. And what is the electric current? Dynamic electricity or electric current is the uniform motion of electrons through a conductor. The metal like the copper, iron, gold, aluminum, and silver are the best material for conducting electricity. And we had the definition of a circuit. A circuit is an unbroken loop of a conductive material that allow an electron to flow through the continuously without a beginning or ending. And that is the circuit. We have two types of current. The first one is direct current or DC. It's the undirected flow of electric charge and the flow of electricity in the single direction from the negative to the positive terminal. And DC is produced by the source such as the batteries, solar cells, or AC-DC converter. And another one is alternating current, AC. AC is an electric current in which the flow of electric change periodically reverse direction. The usual waveform of AC is small electric power circuit is the cyclic, and AC is the form in which the electric power is delivered from the business to the resident. And DC may be converted to AC with an inverter or motor generator. Next, I will introduce about the voltage, current, and resistance. Voltage is the measure of specific potential energy per unit change between two locations. And when a voltage source is connected to a circuit, the voltage will cause a uniform flow of electrons through that circuit. That's called the current. And resistance is the measure of opposition to electric current. When we connecting two poles of a source directly with a wire, the amperage will be very high in the unloaded circuit, resulting in a huge release of energy, usually heat power. This phenomenon is called the short circuit. And an open circuit is the one where the continuity has been broken by an interrupt in the path for electrons to flow. And a closed circuit is the one that is completed with a good continuity throughout. Next, we will introduce about the element in the electric circuit. The first one is resistor. Resistors are the device built to provide a precise amount of resistance in electric circuits. Resistors are the rate both in the term of their resistance, ohm, and their ability to dissipate heat energy. We have two types of sources. The voltage source is the electrical energy source that always delivers and maintains a constant voltage level. And the second one is current source. It provides a constant current. Beside the resistor and source, we have the capacitor and inductor. The capacitor reacted against change in the voltage by supply or drawing the current in the direction necessary to oppose the change. The ability of capacitor to store energy to the form of the electric field is called the capacitance. The capacitance is measured in the units of farad. And inductor reacts again change in the current by the drop the voltage in the polarity necessary to oppose the change. The ability of inductor to store energy in the form of magnetic fields is called inductance. Inductance is the measure in the units of the Henry. Next, I will introduce some fundamental electrical law. First one is Ohm's law. Ohm's law is a very important law. It shows the relationship between the voltage, the current, and the resistance. Let's see the equation. We have E equal IR, with E is the voltage, I is the current, and R is the resistance. Let's see an example. We had a circuit with the source 12 voltage and a lamp with the R equal 3 ohm. Now we will calculate the current through the circuit. I equal E of divide R equal to 12 divide 3 equal to 4 ampere. The second law is the Joule law. The Joule law discussed about the mathematical relationship between the power dissipation and the current through the resistance. We have the equation P equal I square R or P equal IE, with P is the power. Let's see a sample. We had a circuit with battery E equal to 18 volt and lamp R equal to 3 ohm. We can calculate the current through the circuit. I equal to 6 ampere. And we can calculate the power P equal IR equal to 108 watt. That means the lamp is releasing 100 watts of the power, most likely in the form of both the light and the heat. Before go to the third law, the Kirchhoff law, I will introduce the definition of the branch, node, and loop. The branch is a series of elements such as the voltage source, current source, or the resistor. And the node is the point of the connection between the three or more branches. And loop is the any closed part in the circuit. And this circuit has the fourth branch, 2 nodes, and 6 loops. And now, Kirchhoff law. Kirchhoff law includes 2 laws. The first one is Kirchhoff current law. This says the sum of all current entering and existing of a node must be equal to 0. And the second one is the Kirchhoff voltage law, KVL. This says the sum of all voltage in the loop must be equal to 0. That is the Kirchhoff law. Next, I will discuss about the analysis of DC circuits. I will introduce the serial and parallel circuits. The serial circuit. In the serial circuit, the voltage drop as to equal the total voltage, and all components share the same current, and resistance as to equal the total resistance. You can see equation. And parallel circuits. In parallel circuits, all the components share the same voltage. The branch current as to equal the total currents, and resistance diminished to equal the total resistance. And you can see the equation. Now we will talk about how to analyze the serial parallel resistance circuit. To analyze this circuit, first we will simplify the original current down to a simple circuit with the one equivalent total resistance, and redraw the current diagram for each simplification step. And next we will solve the simplified current with the total resistance and calculate the total current. And finally, we will calculate the voltage drop current for each element. However, in many circuits, you cannot simplify the original circuit down to the simple circuit with the one equivalent total resistance. In this case, you have to use the branch current method or the mesh current method. Now I will show you how to analyze the circuit using the branch current method. The step 1, you have to choose the node and assume the direction of the current. And the step 2, you have to find the relationship between the current using the Kirchhoff law and the Ohm's law. At step 4, you have to solve the unknown branch current using the relationship between the current you find in the step 2. The second method is the match current method. This method is similar to the branch current method, but it don't use the Kirchhoff current law. It only uses the Kirchhoff voltage law and Ohm's law. The step 1, you draw the mesh of current in the loop of circuits enough to account for all the components. The step 2, you make the relationship between the current using the Kirchhoff voltage law and the Ohm's law. And the step 3, solve the unknown mesh current. And then you can find the voltage and current for each component. It's the mesh current method. Next, I will talk about the network theorem. The first one is Millman theorem. Millman theorem applies to any circuit rho as a set of parallel kinetic branches. Each branch with each hour voltage source and serial resistance. You can see the figure, and we can calculate the voltage across all the branches using this equation. And next, I will introduce the superposition theorem. For this theorem, you can separate the original circuit to the two small circuits with only one the power source and calculate for the small circuit. And then we will combine two small circuits. And two other theorems is the Thevenin theorem and Norton theorem. The Thevenin theorem is a way to reduce the network to an equivalent circuit composed of single voltage source, zero resistance, and zero load. You can see the figure. And the second one is Norton theorem. Norton theorem is a way to reduce the network to the equivalent circuit composed of single current source, parallel resistance, and parallel load. And finally, to conventional for analyze the circuit, you can transform the delta network to the Y network, or from the Y network to delta network using this formula. And this is the last part of this week.